Okay, this is scenario 2 for the test review, and it'll cover problems 18 to 30 in the Google on the Google form. And it says, for many years, the medically accepted practice of giving aid to a person experiencing a heart attack was to have the person who placed the emergency call administer chest compressions plus mouth-to-mouth resuscitation to the heart attack patient until the emergency response team arrived. However, some researchers believe that chest compressions alone would be more effective. In the 1990s, a study was conducted in Seattle in which 518 cases, we have a sample that a total of 518 cases were randomly assigned 278 to chest compressions plus MMR. So this is the 278 here, and 240 to chest compressions alone. A total of 72 patients survived the heart attack, 29 in a group of CC and MMR. All right, so this one goes to the CC MMR. And 43 in the chest compressions alone. So 43 goes with the chest compressions alone. And then they say, let P1 equal the true population proportion of heart attack patients who survived using CC alone. And let P2 equal the population proportion of heart attacks who survived using CC plus MMR. Just to help us get organized, they've already defined it for us, so we're not going to need to redefine it. I'm going to just make a little note to myself that P1 equals, and they said P1, they specifically said chest compressions alone. So P1 equals CC alone, and P2 equals CC plus chest compressions plus MMR. That's what they gave us. So that means P hat 1 equals X1 over, excuse me, X1 over N1. And we just said 240 got chest compressions alone and 43 of them survived. It's not a whole lot of them. So 43 out of 240. So that means X1 is 43, N1 is 240. And if I take my calculator, 43 divided by 240 is about 0.1791. So that's going to be P hat 1. And then P hat 2 is going to equal X2 over N2. And in the other group, 278 got chest compressions plus MMR. And of those that got chest compressions plus MMR, 29 of them survived. So you have to be really careful to organize this. It'd be really easy to get this all messed up. And so I'm going to go 29 divided by 278. And I end up getting 0.1043. Well, clearly we have a difference in proportions. All right. But let's see what this says. It says conduct a test with a significance level of 0.05 to determine whether or not there is a difference in survival rates between the two methods. So what they're saying is, hey, yeah, we know that there's a difference here, but is it statistically significant? And the key word is, first off, they want us to use an alpha of 0.05. So there's our alpha level. And they want to see if there's a difference, and the word difference lets me know that I'm working with a not equal. So I'm going to go ahead and write my null and alternative hypothesis, HO. The null is going to be P1 equals P2. And the alternative, P1, and since I use the word difference, this is going to be a not equal to P2. The next step would be to define my parameters, but they've already done this. All right, so P1 equals CC alone, and P2 equals CC plus MMR. And since they've already defined it, I don't need to redefine it. So we're not going to do that part. We don't have to. They've already done it for us. Now we need to do our conditions, and the one condition we check is we're going to sit there and go, well, is it large enough? And so N1 P1 or N1 P hat N1 P hat 1 must be greater than or equal to 10, and N1 Q hat 1 must also be greater than or equal to 10. And in this case, we're going to go 240 times 0.1791 equals 43. So that's greater than or equal to 10. And then we're going to go 240 times 1 minus 0.1791. Oops. And multiply that out. We end up getting 197. And that's greater than or equal to 10. So the first sample is large enough. Doing the same thing for the second one. Into P hat 2 has to be greater than or equal to 10. And into Q hat 2 must be greater than or equal to 10. So this is going to be 0.1043 or 278 times 0.1043. That equals 29. And this is going to be 278 times 1 minus 0.1043. And that equals 249. Both samples are large enough to approximate with the normal. All right. So that takes care of that one. And we've done that. So the next thing we need to do is we need to go ahead and write our equation. Well, our equation is Z equals P hat 1 minus P hat 2 over the square root of, be careful here, P hat C, Q hat C, N1 plus P hat C, Q hat C over N2. Well, we know we have P hat 1. We know we have that. We know we have P hat 2, but I don't have P hat C. So I've got to go ahead and calculate P hat C and Q hat C. So P hat C equals X1 over N1 plus X2 over N2, which equals, well, we said that the X1 was 43. So this is going to be 40, this part's 43 over 240. That should be a 4 plus. And 2 was 29 over 278. So P hat C in this case happens to equal 72 over 518. So P hat C equals 0.1389. and Q hat C, because we're going to need it, equals 1 minus 0.1389. All right, now we have everything we need. We can go ahead and plug in. So P hat 1. P hat 1 was 0.1791 minus 0.1043. And this is going to take a really big radical. I hope I have enough room for it. Because we're going to go 0.1389, that's P hat C, times 1 minus 0.1389 over N1, which was 240, plus P hat 2 was 0.1043, 0.10, excuse me, P hat C, because we're using P hat C, which is right here, and we calculated that right there. So 0.1389 times 1 minus 0.1389. And our value was 278. So we want the probability. So we want this Z, we were looking for the Z-score. And what do we get when we do this? So at this point, we can go ahead and plug in. We've done all the hard parts. So we should be able to check ourselves out and run this thing. So stat test, 2 proportion Z test. X1 was 29. Excuse me. I need to swap those around. So X1 was 43. N1 was 240. X2 was 29. N2, 278. We had a not equal. And we go ahead and calculate. And we end up getting Z equals 2.4555. So that means our p-value equals 0.0140. And we had an alpha value of 0.05. This is our p. Our alpha is 0.05. 140 is definitely less than 500. So we're going to reject the null. All right, we're going to reject the null. Our null was that they were equal, and here they're going to say they're not equal, they're not the same. So we're going to write our conclusion. Our p value is 0.0140. We reject the null. There is sufficient. We have enough evidence at alpha equal 0.05 to believe or to suggest that the true population difference in proportion CC alone minus CC plus MMR is different that it's different. All right. You could have also said to suggest that the true population proportion of heart attack patients who survived using CC alone was different than using the true population proportion who had CC and MMR. All right. But basically, you need to make sure that you're comparing the two. That's a lot of work for that one. All right. And so we've done the first part. We need to go ahead and do what is our Z star value. So we're going to need to go ahead and set up our confidence interval. So create a 95% confidence interval for the scenario. So if I'm creating a 95% confidence interval, and I'm going to keep this nearby because I'm going to refer back to it. Well, the first thing we always need to do is define them. Well, they already did that. They already said P1 equals CC alone, P2 is CC plus MMR. We have those values, so we don't need to redo that part. They defined the parameter for us. They said, so we don't have to do that. They've already said, once again, CC, P1 is CC alone, P2 is CC plus MMR. And we've already done the conditions, so we don't need to do the conditions again. So all we need to do is start with writing our equation. And our equation for the confidence interval is P hat 1 minus P hat 2. And I'm going to put CC, and this is CC plus MMR, so we don't get confused. It's not required to do it, but it might help us out. Plus or minus Z star. And here we need to be careful. This is not a PC. This is a P hat 1, Q hat 1, N1 plus P hat 2, Q hat 2, N2. And like I said, be careful because this underneath the radical here is P hat 1 and Q hat 1. And on the hypothesis test is P hat C and Q hat C. So we have to be careful of that difference. The good news is we have most of this information already. We already know that P hat 1 is 0.1791. So 0.1791 minus P hat 2 is 0.1043 plus or minus. We'll leave a space for Z star and come back to it. Need to make a really big radical so I have enough room for all this stuff that goes underneath here. And P hat 1 is 0.1791. 0.1791. And Q hat 1 is just 1 minus that, so 1 minus 0.1791 over N1 is 240 plus 0.1043 times 1 minus 0.1043 over 278. So here we go. We need to calculate, they want us to do a 95% confidence interval. So I need to, since they want us to do a 95% confidence interval, I need to look up a Z star value for 95%. So second bars, inverse norm, parenthesis 1 minus 0.95, close parenthesis, divided by 2. And I end up getting a value, and we're going to make it positive as always, is 1.96. So this would be 1.9599. So there's my Z star value. And at this point, I can go ahead and calculate this thing. So stat, test. And we're going to scroll all the way down to letter B, I believe it is. Yeah, 2 proportion Z interval, which is letter B. And we have 43 over 240, because that's our X1 value. And that's what we had up here. And then we had our X2 value, 29 over 278. And we need to make this a 95% confidence level. And when I do that, I end up getting 0.0148 and 0.1352. So my confidence level is 0.01448. This is my lower bound. And my upper bound is 0.13552. So here's my lower, and here's my upper. So there's our lower and our upper. And I want to point something out real quickly. Please remember, we went CC minus the CC plus MMR. That was the order we went in. So this is positive. So because this is positive, CC must be greater than CC plus MMR. That's going to be important. All right, CC is greater than, because this is positive, because if this had been negative, CC would have been less. The survival rate for CC chest compressions alone would be less. But because it's positive, the survival rate for chest compressions alone was greater. So because these are both positive values, we know that it's great that chest compressions alone had a larger survival rate based on our confidence interval. So we've identified the lower bound and the upper bound. At this point, we need to go ahead and write our conclusion. So our conclusion is we are 95% confident that the true population proportion of those who survived chest compressions minus CC plus MMR is or lies within the interval .01448 to 0.13552. So we're 95% confident that the true population difference in proportion, I guess it's a true population difference in proportion. And I don't have room to write it, so I'm just going to abbreviate diff in proportion of those who survived chest compressions minus CC plus MMR lies within this interval. All right. So we've done everything but part C. And part C says, use your confidence interval to determine whether chest compressions alone had a statistically higher survival rate than chest compressions alone justify your response. Okay, first off, we know there's a difference because 0 does not lie in the interval. And I know 0 is not in there because it doesn't go from negative to positive. But we can go ahead and say, because the interval, and I'm going to put the order we went in, which we went CC minus CC plus MMR is positive, we know that the proportion of people surviving was greater for CC alone. And remember, CC is for chest compressions, right? Once again, we went in the order CC minus CC plus MMR. Because it was positive, CC must have been bigger, all right? So because our interval is positive, and it's positive because these are positive numbers, we know that the proportion of people surviving was greater for CC alone. If it had been negative, it would have been greater for CC plus MMR. If it had contained 0, we couldn't have told a difference, all right? So because 0 is not an interval, and because the interval is positive, we know the proportion of people surviving was greater for CC alone. And in this case, since we wanted to know which was bigger, we don't even have to address the probability of 0. All right, thank you for watching. I hope that helps. Pay very careful attention to this. I think it'll help you with your tests. Thank you.